Hi everyone, I hope you're doing great. Stay sharp and motivated. Let's dive into today's video. We're going to be talking about the Châtelier Principle and the impact of increasing temperature when it comes to endothermic and exothermic reactions. If you haven't watched my previous video, make sure you watch it. I explain endothermic and exothermic reactions there. But let's dive right in. Okay, so we got the first reaction over here. You can see the delta H provided to us, and it's a positive value. Okay, so when you have a positive delta H, positive change of enthalpy, it means you have an endothermic reaction. Okay, so heat is being absorbed right off the bat. You just want to make sure you got your facts straight. The other one is negative on the other hand. Delta H is smaller than 0, it's negative, which means that I have an exothermic reaction over here. Okay, heat is being released. I have my facts down. Let me write it down though on this side. So heat absorbed for endothermic and released for exothermic, okay? So Le Châtelier tells us that when you're adding stress or disruptions to a system, the system will respond to you. So when my heat is being absorbed over here, going back to my endothermic, I'm putting heat on the reactant side, on the exothermic. Since heat is being released, I'm putting it on the product side, right? Because your reaction is happening. And after the reaction is happens, or at least one way, your product is produced, heat is released. Now, so heat on the reactant side for endothermic. Let's just move to the endothermic and take a look at that. Okay, so let me just write this down before I move. Okay. Now, if I'm increasing the temperature or I'm increasing heat, what does that mean? Well, it means for an endothermic reaction, since heat is on the reactant side, I'm favoring the reactants in this case. This is what I'm doing to the system, yeah? So I'm favoring the reactants, all right? As opposed to an exothermic reaction, if I'm increasing heat, increasing temperature, since heat is on the product side, it means that I'm favoring the products. That's what I'm doing, okay? Now, let's go back over here. If I'm looking at the reactions and the direction for an exothermic reaction, it means that I'm favoring the forward reaction. For an endothermic, it means that I'm favoring the reverse reaction. Now, if I'm doing these, so how would the system respond to me? Well, that's when Le Châtelier is going to come in handy. Whatever I do, the system is going to respond to me by doing the opposite. Okay? So, if I'm looking over here for my endothermic, I'm favoring the reverse reaction, so the one that goes to the left. So in response to my action, the system is going to shift right to just make sure that the response counteracts what I was doing, the stress I was putting into the system at equilibrium. For exothermic, because I'm favoring the forward reaction, Le Châtelier says, my equilibrium system is going to shift to the left to counteract what I was doing to it. Okay? So, you first need to understand what you're doing to the system, the stress you're putting into the system, which reaction, which direction you're favoring, and how would the system respond to you based on Le Châtelier. Like and subscribe. Stay sharp.